In section 8.5, we're going to work with inverse trig functions, starting with y equal arc sine x. Y is equal to the angle whose sine is this value. And y must be in this range between minus pi over 2 and pi over 2. That's the range of arc sine x. Or another way of in degrees, that would be between minus 90 degrees and 90 degrees. What quadrants are we talking about? Well, let's look at that as, let's just draw the x and y axis, and 90 degrees, from 0 to 90 degrees, we mean angles in this quadrant, quadrant 1. And between 0 and minus 90 degrees, we mean angles in negative angles in this quadrant. All right, that's quadrant 4. In quadrant 1, sine is positive. And in quadrant 4, sine is negative. All right, that's important. Let's look at the first example. We want to know what the what angle has sine minus root 3 over 2, and the angle must be in this range. So it can't be in quadrant 1 between 0 and 90, because then this value would be positive. Sine values are positive there. So it must be in this range. It must be between 0 and minus 90 degrees. So we're looking for, more specifically, an angle whose sine is minus root 3 over 2, and this angle is between 0 and minus 90 degrees. So that would be an angle with reference 60 degrees. Okay, and in that range it would be minus 60 degrees. Or in radian form, that would be minus pi over 3. The function y equal arc tangent x has this almost the same range as arc sine. The range is between pi over 2 and minus pi over 2, just not including those two angles, or between 90 degrees and minus 90 degrees. All right, once again, that would be between 0 and 90 degrees, that would be quadrant 1. And between 0 and minus 90 degrees, that would be quadrant 4. Negative angles in quadrant 4. All right, so we're looking for the angle whose tangent is minus 1 over square root 3, so that must be this quadrant, because here all tangent values are positive, so we must be in quadrant 4. It must be a negative angle in quadrant 4 and remember that the tangent of 30 degrees is 1 over square root 3. So we must be talking about an angle whose reference is 30, reference angle 30, and it's a negative angle, so we must be talking about minus 30 degrees. All right, so this is equal to minus 30 degrees in degrees, or in radians, minus pi over 6. In number 3, we're looking at the tangent of this angle, arc sine square root of 2 over 2. All right, so first of all, what's this? What is arc sine square root 2 over 2? Well, this is an angle whose sine is root 2 over 2, and it must be in quadrant 1 because it's a positive value. We know that if we're talking about positive sine values, then the angle is necessarily in quadrant 1, or negative sine values, the angle must be in a negative angle in quadrant 4. That's because of the range of arc sine. So we know that the sine of 45 degrees is square root 2 over 2. So this must be 45 degrees. Okay, and so now we want to find the tangent of 45 degrees, and that's equal to 1. In number 4, we want the cosecant of this angle. This is an angle whose tangent is 4 over 5. So let's call this angle theta. And let's draw a triangle containing theta. So theta is an angle whose tangent is 4 over 5. That's opposite over adjacent, opposite 4, adjacent 5. So there's a picture of theta. Now we want the cosecant of this angle. Remember that cosecant x is 1 over sine x. Sine is opposite over hypotenuse, so cosecant's hypotenuse sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So we need the hypotenuse here, so let's figure that out using Pythagorean theorem. So we have 5 squared plus 4 squared. That's equal to the square root of 25 plus 16. So we have the square root of 41 for the hypotenuse. So the cosecant of theta is opposite over hypotenuse, so that would be 4 over the square root of 41. In number 5, we want the cosine of the arctangent of minus 4 over 3. All right, again, let's say that this is angle theta. This time, theta is not in the first quadrant. Remember, the range of arctangent, is between 90 degrees and minus 90 degrees. So since this tangent value is negative, we can't be in the first quadrant. We must be between 0 and minus 90 degrees. So so theta must be in quadrant 4, a negative angle in quadrant 4. Let's draw, like we did in the previous example, we'll draw a triangle, not containing theta, but containing the reference angle of theta. So we're going to draw a triangle whose tangent is 4 over 3. So let's just fill that in. And let's find the third side with the Pythagorean theorem. 3 squared is 9. 4 squared is 16. So the third side of this triangle is 5. The hypotenuse is 5. All right. So we're talking about an angle in the fourth quadrant. And the cosine of this angle is necessarily going to be positive. Remember that cosine is positive in the fourth quadrant. Remember this little diagram? All students take calculus. That was the way we remembered which angle is positive in which quadrant. So cosine is positive in quadrant 4. All right, so the cosine of our angle we know is going to be either plus or minus adjacent over hypotenuse, 3 over 5, but since we're in quadrant 4, it's going to be positive. So once again, what we do is we draw a triangle who's containing this angle, whose tangent is 4 over 3. We figure out what the cosine of this angle is, and then based on what quadrant we're in, we decide if the cosine is positive or negative. Since we're in quadrant 4, and that is because the tangent value is negative, so since we're in quadrant 4, we know that cosine is positive. All right, here we're going to do something similar to what we did in the previous examples. Let's call this angle theta. This is an angle whose sine is x. And we'll draw a picture of theta. An angle whose sine is x, that's opposite over hypotenuse. So we'll label these sides opposite x, hypotenuse 1. All right, so this is an angle whose sine is x, and we want to know the tangent of this angle. So the tangent would be this side over this side, opposite over adjacent. So let's figure out the adjacent. Using the Pythagorean theorem, the adjacent is 1 squared minus x squared. All right, so the tangent of this angle is opposite over adjacent, x over square root 1 minus x squared. Number 7 involves the derivative of an inverse trig function. So let's just write down the derivatives of some of the inverse trig functions, starting with arc's sine. Okay, so the derivative of arc sine x is equal to 1 over the square root of 1 minus x squared. And let's do the derivative of arc tan. And that's equal to 1 over 1 plus x squared. And now the derivative of arc secant, that's equal to 1 over the square root of x squared minus 1, and on the outside we have the absolute value of x. So the derivatives that we're going to be doing will be based on these three derivatives. All right, so here we want the derivative of the arc sine of 5x cubed. So using the chain rule, in the denominator we have the square root of 1 minus this squared. So that's 5x cubed squared. And now we're going to multiply, use the chain rule, multiply by the derivative of 5x cubed. So that would be 15x squared in the numerator. In number 8, we want the derivative of arctan e to the x. So let's do that. Derivative with respect to x of arctan e to the x. So in the denominator, we have 1 plus this squared. I'll just write e to the x squared. And then we're going to do the chain rule, multiply by the derivative of e to the x, which is e to the x. Let me just rewrite that as e to the x. And in the denominator, I'll just square this out, 1 plus e to the 2x. And then number 9, we want the derivative of the arcsecant of 7x. Let's write that out. So in the denominator, first we have the absolute value of 7x. And we have the square root of this quantity squared, 7x squared minus 1, times the derivative of 7x. So we have a 7 over there. Let's just simplify this a little bit. We can bring the 7 out of that absolute value. And underneath the square root, we can square this out, and we have 49x squared minus 1. And we'll just cancel those 7s. So we end up with 1 divided by absolute value of x, square root, 49x squared minus 1.